Hello, world viewers. What's up? I hope all you are doing well, and your viewers and your viewers are also doing well. In previous video, I described about the derivation of E is equal to mc square, and also I described about the application of the E is equal to mc square, right? And if you remember in that video, I told that I use Doppler effect, and I will derive that Doppler effect in the next video. I tell that okay. In this video, I will derive the Doppler effect equations. Those we are using in the frequency of blue shift and the frequency in the red shift. I use the equation. Just remember that FB is equal to, I use that some frequency C plus B root over C minus B root over. It is for the blue shift frequency, right? And it is the normal frequency. And this is C plus B, C minus B when the source is approaching towards it. And what is the red shift? For red shift, I use F C minus B root over upon C plus B root over, right? So in these two equations I use on E is equal to mc square. In today's video, I will derive it. So we use these two equations. In this video, we derive those equations. We are using that on the light medium. Okay, in the light medium means light never requires any kind of medium to travel. But Doppler effects happens in everything. I mean, it happens in the sound waves as well. But what happens here? Sound waves comes under the classical mechanics, and it comes in the quantum mechanics. Why? Because the speed of the sounds is very less than c, and it is not comparable to the speed of the light, which is not under the speed of light. Then it will be not under calculated under the light sections, right? So we will derive relativistic Doppler effect. But previous that we just throw a formula which is used in the classical mechanics. We just try to understand that formula, not to derive that. We have to derive this. Okay, that is no relation between this and that. But the things are very similar to you. What happens in the classical mechanics is that you will see. You will see the Doppler effect happens in the sound waves in your day-to-day life. If you are going on the road, various kind of vehicles are sounding like bang. You know it? Have you ever listened it or not? Okay, I will see you a demo. Look at this. Look at this. Right? When the vehicle is from far away from you is small, and when it's close to you is higher. How it looks, how the waves maybe looks like this. This is when it is far to you. When it's near to you. That means it is very. The crash starts happening very closely when it is near to you. For example, you are standing here, right? So what happens in the classical mechanics Doppler effect? There is a source. Let's say this is the source. Okay. This is the source. It creates sound waves. Let's say sound waves. And this is you, the observer. Let's say this is the observer. Okay. So what happens here? The observer looks. This is the observer. This is the source. It has some velocity. It is in x motion. And let's say it is in v velocity. Let's say it is vs, right? And it has a frequency. Let's say it has f. And the observer, the velocity is coming towards it. That is, let's say vu. And that frequency looks like to it like f dash. The frequency is f, but for the observer, the frequency is like what? F dash. So we have to calculate in the formula, that is what is f dash. What happens here? Here the source is going towards the observer and the observer is coming towards it. It has some frequency that is f, and it has some frequency that is f dash, right? So what is the formula for it? That is f dash is equal to f multiplied by source of sound, the speed of the sound in any medium plus the velocity of the object upon speed of sound in any medium minus the velocity of the source. Okay, this is the formula for the classical mechanics. It is for the classical mechanics, right? So what happened here? The v is very smaller than c. It is not coming under the speed of the light. It comes under like very small, so it will not go to the Doppler effect which is happening in the light. It will not go to the quantum mechanics. So for that, we have to derive others. This formula is not even relatable to what? Not even relatable to other source. We have to derive that particularly. So no need to be about look at this a lot. It is just a demo. I just want to show you that this kind of scenarios happens. Okay. So what's happened in the derivation when we apply it? I say there is a source. Just erase it, right? I am saying that on that video that there is a source, radioactive element which emits some kinds of energy. It emits some kinds of energy. And I am with the Albert Einstein. I am coming with the rocket, right? I am going towards it. With the rocket. Do you remember this? This is the Einstein was sitting there, and he also taking towards. He also calling me that come with me, and I will said that okay sir, we will go. And the rocket is going a v velocity, right? For us, we are going in the v velocity, but how it looks? It looks like it coming towards us in the v velocity. It has maybe it has not any kind of speed, but for us it looks like that. For example, if I am going on a vehicle and the trees are going backward and backward, you see trees are moving. No, trees are not moving. You are moving, right? So you are moving in the v velocity, but it looks like it is moving towards you. That means it is in motion according to the s dash frame. This is s frame. This is s dash frame. Okay. If we say it radiates some kind of energy, we are going to see the scenarios. How Doppler effects. Before we are seeing this, what happens here? What this source doing? Let's say this source is doing fast wave in 1 second. In 1 second, it doing fast wave, second wave, third wave, fourth wave, and fifth wave. So we are seeing that in 1 second it creates 5 waves. 5 waves. What does it mean? It means it is its frequency. In 1 second, the number of waves created by any source is known as its frequency. And we will see another things that is in 1 second it is 5 waves. Okay. If I are going to calculate the other things, so here the frequency is 5. Okay. We are going to a smaller formula, that is speed is equal to distance upon time. We know it from the simple mechanics, classical mechanics, distance upon time. And what is distance? Distance is equal to speed multiplied by time. So what happens here? Look at the fast wave scenario. The fast waves at first generated for this, then the fast wave come to this position. This is the fast wave actually, and this is the second wave, this is the third wave, this is the fourth wave, this is the fifth wave. Actually the fast wave is in the outermost cell. Okay. So what will be the distance? What will be the distance from this point to this point? Okay. We will do it, right? This is the time factor. That is time factor is equal to 1 second. So time is equal to 1 second, and speed is equal to c. Time is equal to 1 second. Then what will be the distance? Distance is equal to speed multiplied by time. That is c into 1 second. That is c meter. Okay. From this to this, its distance is c meter. It's c meter. Why I use meter? Because I here use second. The SI unit of time is second. The distance is meter. We all know it. Okay. What happens here? If we do the simple calculation, 5 waves takes how many distance? It takes c meter. Okay. It takes c meters. That means one wave takes how many meter? That is c upon 5. What is one wave distance? It is called the wavelength. We all know, and it is symbolized in the Greek letter, that is lambda. So lambda is equal to c upon 5. What is 5? 5 is the frequency. We all know 5 is the frequency. So lambda is equal to c upon 5. In the same case, the frequency is equal to c upon lambda. The frequency is equal to c upon lambda. Okay. So this is the equation, we got it. Alright. Then we will go to the next step. This is the wave simply doing its motion, right? Without anyone is doing these kind of things. The waves are going like this. What happens here? when we are moving in the motion v, we are means we I am not Einstein, I am with the Einstein, right? Okay, so what happens here? The v, we are in this motion, and the waves are don't look. It will not look like this. Look like this. It will look different. It will look different. Why? We are going in the speed, and those waves are looking like compressed. Here, compressed. I mean, here it looks like this is one wave. This is two waves. This is three, four, and I mean, from this side it will be closer and closer, but inside it will be wider and wider. Why? Because we are moving in a motion. Moving in a motion. So the sea lies under this. The center lies should be in this, but it is here. It is here. Why the shift? Why the shift is happening? Why the shift was happening? Because we are moving in a v velocity. We are moving in v velocity. Okay. Here, so this distance will be the total distance will be. The total distance will be c, but here we shift from this to this. Why? Due to v. That means what will be the distance for it? The distance for it, speed is equal to distance upon time. Okay, speed is equal to distance upon time. That means distance is equal to speed into time. What is the speed here? V speed into 1 second. That is equal to v meter. Okay, so this movement is v meter. Okay, then what will be the distance? This total is c and this fraction is v. That means what is this? This is c minus v. That is c minus v. Minus v meter. That means it shifted c minus v meter. Okay, c minus v meter. So we can say the five waves takes how many? C minus v meter. Okay, then what will be the one wave take? One wave take c minus v upon 5. C minus v upon 5. And what is the 5? 5 is the frequency. 5 is the frequency. So we can say the one wave's length. That is one wave distance means one wave length. Here the lambda is equal to c minus v upon f. This is the f. And we have to find out there is a frequency formula. That is frequency formula is c upon lambda. So we can apply it. So what will be the frequency for the blue shift? And is the red shift. Why I am naming this like? Why I call it blue and why I call it red? Because we know there is a spectrum. This is V gear. It looks bluish and it looks reddish. When you go to here, it looks bluish and bluish. Here the frequency is higher in left side and the wavelength is lower. But here it is opposite. Here the frequency is lower and the wavelength is higher. Okay. So here what happens? This is known, let's say FB. FB is equal to what is the lambda here? This much. C upon this much. C minus V upon F. It will be go to upside. That means FC. FB is equal to FC upon C minus V. It is the blue shift. Blue shift means here contraction is happening. The waves are contracted here. Alright? That means it takes maximum energy. Here the energy are more and more rather than the red shift. Alright? Okay. So this is the formula. So here if you say V, if you put V0, if there is no motion, then it will be V will be 0, CC will be cancelled out. The FB is equal to FC. Everything is alright. Okay, everything alright. The formula is very good. We are seeing. My say Einstein, sir, everything is alright, sir. Nothing to happen. This formula will apply there. Then Einstein says, "Oh, Sudeepta, you forget something. You forget something. What you forget? You forget about the time dilation factor. The time dilation factor. Why time dilation happens? We will know about what is time dilation, what is relative mass, what is relative motion. We will know from next to next videos, because I am telling about the crown to taller, crown to lower. Okay, I tell about the E is equal to MC square, then Doppler effect. I will then discuss about the time dilation. So you are not worried about that, right? So time dilation happens when the speed is very, very closer to the speed of the light. Then time dilated. Then the dilation of time happens, right? So the time dilation symbolized as gamma. it is gamma. Gamma is equal to 1 by 1 minus b square upon c square root over. This is the gamma factor. It is time dilation. Okay, you can say it is time dilation. So friends, we are going in the v velocity, and there is also speed of light. We are in the space, so time dilation also happens. Said Einstein to me. Yes sir, you tell me the right thing. Okay, we just have to divide by time dilation, nothing to worry. What have to do? Just multiply by 1 upon time dilation factor, that is gamma. Okay, so you say okay, this is the formula. But what was our formula? We have the blue shift formula, that is equal to f into c plus b root over upon c minus b root over. Okay, so where is that? This is the simplification. We will do it. Don't worry, we will do this. So how the simplification will happen? Let's do with me and look with me. Just simple mathematics happens. Okay, so we find fb is equal to f into c upon c minus b into 1 minus gamma. Not to be confused, this is not small c. It is for blue shift. It is for the speed of the light. It is capital C. Don't to say that this is f, this is fc. No. It is f is multiplied by c. Okay, so this is the gamma factor. That's equal to fc upon c minus b into what is 1 by gamma? That is 1 by gamma is equal to 1 minus root over. Okay, so it will be 1 by this much. That means 1 upon, that means it will be go to top side, 1 minus b square upon c square root over. Okay, root over. So what will have with this is f. Okay, this is c into 1 minus b square upon c square root over upon c minus b. Okay, so this is f. If we took c2 inside, what will happen? It will be c square. Okay, minus c square will be cancelled out, then it will be b square root over upon c minus b. And what we know? C square minus b square is c plus b multiplied by c minus b. We all know it. It is a simple formula. C square minus b square is c plus b into c minus b. That's equal to f c plus b root over into c minus b root over upon c minus b. And what is c minus b? C minus b is nothing. It is the c minus b root over multiplied by c minus b root over. What is 5? 5 is equal to root over of 5 multiplied by root over of 5. What is 2? Root over of 2 multiplied by root over of 2. What is Sudeepta? Sudeepta is root over of Sudeepta multiplied by root over of Sudeepta. When root over multiplied, then it will 1. We all know it. Not to be worry about that. So it will be f c plus b root over multiplied by c minus b root over. That will c minus b root over multiplied by c minus b root over. C minus b root over will cancel out. Okay, this will be cancelled out. So how much will it? F c plus b root over upon c minus b root over. That is f b is equal to. We got this point. Okay. The simple style, the same style, these things will be solved. And the same style we will find. Sorry, I have a little bit of cough. Okay, so what happens here? Here this formula will be comprised to that how it when we are going towards the source, when we are going towards the source, or the source is coming towards us. The two things for that this formula. This is for the approaching formula. This is for the approaching formula. But when it is going nearer, further to further, then this will be. This is for FB and this is for FR. I think you are. Your understanding for the Doppler effect for the light, I think you got some point. And don't need to worry about the notes. Okay, I will provide you, I say it. Right? So don't need to worry. So what we see in the total scenarios? In the total scenarios, we are seeing that relativistic Doppler effect plays a major role for deriving that E is equal to mc square formula. Right? In the previous video, I tell that for we got E is equal to mc square. Einstein also says that various kind of equations plays a major role. So from one of them, Doppler is also James Doppler. is also one of them. Doppler effect happening in every medium, like in the water medium, in the air medium, in others medium, here also in the light medium. Why the light medium is special? Light medium is special because of it has some kind of that kind of characteristics. It is very not similar to the physicality what he was seeing. Here the quanta are flying same as well, the photons are flying that. Okay, so studying the mechanics of other things, but studying the mechanics of light is very different, right? So these are the scenarios. I hope you understand this. I try my best to understand you. Still, if you have any doubt, please write it in the comment section. That is in the other video. I always tell about, and I will definitely answer you those questions asked by you. Okay, here I conclude my videos by saying thanks you for watching this video.